Hi everyone, and welcome to this session on developing AI integration in domain-specific tools with Theia AI. Let me just share my screen and get right started. So now all should be set. Hi again. My name is Philipp Lange. I work with Eclipse Source, which is a technology provider and a technology partner focusing on building specialized IDEs, custom tools, domain-specific modeling environments. And obviously, in the last 1 or 2 years, AI capabilities and the integration of those capabilities into such tools has become a very, very important topic. So we've been very busy in integrating AI into several different tools. We've been so busy with it that we thought it would be a good idea to even provide a framework around that, and that's Theia AI, which Jonas already mentioned briefly in the first presentation he gave. And in this talk, we really want to focus on that framework from the perspective of a tool adopter, and give you some experiences and techniques that you can use to build AI capabilities for your domain-specific tools. So what is this all about? What do I even mean with AI capabilities? I think I don't need to go too much into detail because I think all of you will be aware of the very, very popular tools like GitHub Copilot or Cursor IDE, and all of these great tools that enhance the productivity of developers quite a lot with intelligent code completion, context-aware chat windows, maybe even code generation capabilities, or more even agentic things like, do you want to create this file? Let me do that for you, and stuff like that. And what this talk is about is how can we actually build similar capabilities, but for our custom tools based on Eclipse Theia. So that means we will have to deal not only with what Copilot does, but also deal with non-textual editors, domain-specific languages, maybe even more specialized knowledge that is relevant in our custom domain, custom data models, and the semantics behind all of that. And to give you just a very brief example of how something like that could look like, I mean, AI capabilities in a domain-specific tool, I have here a Theia application with a very simple diagram editor that has basically a concrete syntax with colors, boxes, edges, and stuff like that. And behind that, there is a specific semantics. And next to it, I have the chat window. And now I, of course, want to be able to ask questions about this diagram. So for instance, I could ask now, how many tasks are executed in parallel at maximum? And the AI here is capable of giving me an answer and says the diagram consists of one fork node enabling 2 parallel flows. So that's perfect. That's really a correct answer. So that means that the AI can actually understand not only what is the state of the diagram, but also what is the semantics behind it, what is the meaning of each of these nodes. We can then, of course, even go further and ask it, yeah, please help me to create new reasonable next nodes here after brew. Let's see what the AI will come up with. Now you see it can not only understand the diagram, but it can even interact with the diagram editor by creating new nodes and connect them and stuff like that. Other examples for good use cases is sometimes we may even need to pull in more context to understand and give answers to certain questions about this diagram. So for instance, I could ask, what does check TP and check WT even mean? So it's not specified in this diagram, but still now the AI can basically retrieve additional artifacts like a documentation that might be behind this diagram to give an answer like, okay, check TP actually stands for checks temperature and check WT stands for check the weight. And now I could, for instance, tell it and go into even more complex workflows. Actually, that's not correct. I'm the designer of that. The check WT is actually short for check water level. Can you please correct that? And what the AI will do, it will update the diagram and it will update the underlying documentation and show me a diff so that I could, for instance, say, okay, that's correct. We update that to water. So this is just a very, very small, simple example, but this should give you an idea of where we are wanting to aim at with this whole framework. And this whole example is, of course, built on Theia AI, the framework that I mentioned. So what is Theia AI in more detail? Theia AI is a framework for integrating AI capabilities into custom tools or IDEs built with Theia. It is part of the Eclipse Theia codebase, so that means it's also open source, vendor neutral, all the cool things about Theia itself, and provides you reusable components, libraries, UIs, and stuff like that in a Theia native way, so that it's very, very easy to integrate AI capabilities into your tool. Basically, the heart of it is a framework of and around agents. So you can build essentially agents that can be extended with variables, tool calls. I will go into more detail about all of that. And those agents can talk to LLMs and integrate their capabilities either via a language model registry or by just talking to them directly. And these agents are then available to be used within a chat or from within any other UI component like menu items and stuff like that. And all of that is really designed to give adopters full control over where and how AI is integrated, which LLMs are used, whether it's on-prem, local, or off-the-shelf service, LLM services, which tool data you actually share with the LLM, and which behaviors you're actually executing, and which actions are in the tool. So that's really full under your control. So let's have a look at the first main part of Theia AI, and that's agents. So agents are essentially the mediator between, on the one hand side, your tool, using its tool API and stuff like that, and on the other side, the LLM. So that means it encapsulates really everything from the prompting, the context augmentation, LLM communication, tool actions, and all of these things. So it has full control over the prompting. Let's have a look at that. Before I go into detail, however, I would just give you a very, very short primer in how LLM completions work, just in case you have never communicated with an LLM via the API, so that you have a rough understanding. So essentially, if you are writing an agent, you have full control over the communication to the LLM. And what that is, in the simplest way, is essentially you provide a prompt to the LLM and get a response. And the prompt is essentially a list of messages that are tagged by the role, for instance, a system message, a user message, an assistant response, and a user message. And basically, that's in the full control of your agent. That's what you drive when you implement your agent. And obviously, this enables you to do all the typical prompt engineering techniques, basically to guide the LLM's output for a certain user input, because very often, or most of the time, you don't want just to take the user input and provide it to the LLM and return back the response, because that would, with that, your tool integration wouldn't add any value. But what you would typically do is wrap a lot of stuff around the user input to optimize the output for your users. And the first basic thing that you typically want to add, for instance, is instructions in the form of a system message. So a system message is a way to give general instructions for the entire conversation. You typically can define a persona. You can apply in-context learning, where you, for instance, explain, in our workflow example, explain common concepts like what is a diagram, what is the coordinate system about, which nodes are available in the diagram, which edges and stuff like that, what is the semantics behind them, how do they look like, which color do they have, and stuff like that. Then you can give further steps, like if the user wants to create a few things, first create the nodes, then get their IDs, and then create the edges, because you need the IDs of the nodes for creating edges and stuff like that. So you can give either further instructions. And last but not least, you can also define an exchange format that is used to transfer a certain state between the tool and the LLM. And with that, you can basically start off creating your first agent already. So creating an agent in Theia AI is really simple. You basically just create one class that extends, for instance, a streaming agent. You give the agent a name. Then you set the system message. That's the message we just saw on the previous slide. And then you register it and specify which language model you want to have. Once you have that, it's already available in your in your IDE, so that you can chat with it. Let me just show you real quick how that looks like. So now let's go back to the slides. We don't need that. And we have now here at workflow, we have here now this workflow 1 agent. And just to show you what this now can actually do instead of a plain agent, if I just use an unprompted agent here, and ask this unprompted agent, so that has no idea about anything, what does the orange box mean? It will just give you generic stuff because it can't know. It just says, yeah, it could be a code editor or whatever, include warnings, all wrong, right? But with our system message and using our custom agent, it actually can give you the right answer. It can tell you orange boxes represent manual tasks. Right, that's correct. We can also now already ask it what other types of tasks exist in this diagram, and it can give you the correct answer. And that's all just done with the system prompt and the in-context learning. Of course, this is not the end. It's really just the start. The next really important thing is to add additional context, because we want to support things like what is the initial task of the diagram and get reasonable answers based on the state of the diagram that is currently visible. Of course, that's only one type of context. There is many other types of context in a tool integration that you typically need to think about, like domain-specific knowledge, the workspace, the tool state, documentation, and all of that. So what we typically need to do is to think about what context might be relevant for a conversation, extract this data from the tool using the Theia API, and then transfer this into some sort of context format that the LLM likely would understand, like Markdown, JSON, XML. Hopefully, usually you should also explain this format in the system prompt to the LLM, so to help the LLM to reason about this format, and then augment basically the prompt also with this additional relevant context. And there is it's really simple with Theia AI, because there is a concept for that that helps you do that, which is called variable providers. So agents can use variable providers. And a variable provider is just a registered function, essentially, that has access to the Theia API, workspace, services, and stuff like that, and encapsulates this data retrieval. As soon as you've defined your variable, it is available already to be used by users manually, so they can refer to it using the hash. But you can also, of course, automatically add it to an agent. I won't show this into a demo to save a little bit of time, but because essentially it looks like that. So you can ask, what is the initial task of the diagram? Here with our previous agent, the workflow one, it wouldn't be able to give any answer, but if you then give it workflow, then it can actually give the correct answer, because workflow will be resolved into the state of the diagram in a certain format based on which the LLM can provide a reasonable result. And we can even achieve the same thing if we always give the agent access to this variable, and then it could give us the answer right away. Of course, however, we may run into a problem with just adding this context statically, sort of, because with a growing set and complexity of use cases, we also have an expanding range of different contexts, increasing volume of relevant context. And if we all put that into every single prompt that we send to the LLM, we are really running the risk of overfilling the context window, which on the one hand side will increase cost and response time, but even more importantly, it will potentially degrade the quality of the responses if we add too much irrelevant data. So what we really need is a dynamic way of selecting relevant context. And the most typical approach for doing that in the context of LLMs is, I'm sure you've heard of it, is retrieval augmented generation, or RAG. And the basic idea really is that instead of taking a query, going directly to the LLM, you first run through a component to determine, based on a query, which facts are needed, and then add those facts to the prompt and prompt the LLM to answer based on those facts. And with that, you can basically enrich concrete context that is specific to the query, to the LLM response. There is different flavors of implementing that, from similarity search, which is great for document-based use cases, DB queries, tool queries, and so on and so forth. However, in typical tool integrations, we not only have one source of context, but we typically have multiple sources, like documentation, tool state, workspace, and much more. And different requests may require different data sources and retrieval strategies. So for instance, one question may require a code map where we look for a certain thing in the whole workspace to identify the relevant code, or we may contact the language service to get all references incoming for this particular coding construct that you have currently selected, and stuff like that. So what very often is very useful here in these tool contexts is multi-term prompting. And how multi-term prompting extends this process is essentially that before we do this, going to some sort of component to retrieve additional context, we actually use an LLM again to help us to identify which context is actually required. So we could, for instance, write a prompt where we ask the LLM to say, here is a user request. Please determine if answering the user request necessitates the current diagram, maybe additional documentation or some code. And please provide me this classification in a structured output format where you first of all give a rationale. That's usually also helping to improve the quality because you give the LLM time to reason about it, producing tokens. And then you give me a list of required context categories or classes. And based on that, you can then pull in different contexts. So when diagram is specified, you would enhance the prompt with the current diagram state and so on. If documentation is there, you do the same for documentation. If code is there, you maybe then query first the code map and then basically route to the respective context retrieval strategy. And that's also very easily possible to implement in Theia AI. I will really briefly just show a little bit of code to give you a feeling of how that would look like. So let me just switch to VS Code real quick. So this is the workflow agent 3. I will increase the font size a bit. So in a typical chat agent, so that's basically the same what we've seen before. Now it's just 3. Here, instead of just providing a system prompt, we are overriding the invoke method. So, and before we actually invoke the super implementation, we call another agent and say, please classify this request for me. This is essentially an LLM request with the classification prompt that I just shown on the slide. And then we get a classification back. This is really the data format that we are also defining in the prompt. When we use structured output, which many LLMs support, then we don't even have to worry about parsing. So it will give us this data format back. And then based on this data format, we can really write now the business logic and say, if it includes diagram, then we use this context and augment the prompt with it. If we get documentation, we use that and so on. Of course, this can be much, much more complex, or usually is much more complex, but here, this is just a small example. And when we do that, essentially what we can already do now is when we ask this workflow agent 3 now, what is the final task in this diagram? You see here, there was a small progress indication that we've actually doing now a classification, but it can answer this correctly, right? Because here Pru is the last element, and the first step indicated that we need the diagram state in order to answer this. Let's see if we use a second example here. For instance, this one, which functions are called in check TP? That's not specified here, right? But the LLM knows, for this, you actually need to look into the code map. And so we augment the prompt with the code map. And based on the code map, we can actually return OpenCAN, enable LED, and heat pump. And coincidentally, that's exactly what we just provide here if we require code. So just, I think you get the idea. That's what's usually very, very useful. So having augmented the prompt a lot to give the LLM all the context it needs, we now also want to make the responses of the LLMs as actionable as possible to help the user really be productive and directly apply the suggestions of the LLM. And one way of doing that is essentially you specify a format in which the LLM should answer if it wants to create some action or suggest a change or something like that. So here we instruct it to use these create markers. And then we pass this before presenting it to the user and replace these elements with actionable UI elements like buttons or links and stuff like that. And Theia AI allows you to do that in basically the following way. First of all, you can register response content matches where you specify, okay, on this, from this element to this element, I will create a response part of type command, and before that and after that, I will create response type markdown. And then in the UI, based on these typings, we have a list of response part renderers, which can then basically render either buttons or markdown or text or code blocks or whatever you may want to have in your response. So just as a really brief example, if we do just that and say again here, please create two new next steps similar to what we had before. Now you've seen that we've passed out these two buttons, and when I click them, I actually create these elements now. And that's a very, very nice way to make the LLM response very, very easy to actually apply in your tool. The last technique that I just want to show is tool calling. So instead of basically having the agent, having the agent drive this entire flow and augment the prompt and so on, you can also put the LLM into a more agentic position and basically say, these are all the tools that you can use them whenever you feel the need to use them, and decide yourself when you obtain a diagram, when you obtain the documentation, when you create notes and stuff like that. Here are the tools that you call. And once the LLM calls them, a handler is invoked in your Theia application, where you can then actually either apply the change or provide back the result or the additional context to the LLM for further processing. And that's really, really a powerful mechanism. Of course, you need very capable LLMs to be able to do that. But if you have those LLMs at your hand, like ChatGPT 4.0 or something like that, then it's a very, very powerful thing. I don't need to demo that for you, because that's basically what you've already seen in the first demo that I've showed. That was mainly based on tool functions. So you've seen there, sometimes it got the diagram, then it created notes and stuff like that. So that's basically tool functions being called by the LLM. That's also very easy to implement with Theia AI. So far, we've only talked about chat agents. I just want to really briefly say this is, of course, just one way of integrating agents. You can basically integrate agents from any UI component that you may have. So, for instance, if you have a custom editor, you can also talk to your custom agents. If you have a menu item where you would like to invoke an LLM-driven capability, you can also just do that. So just to give you one small example, we've created an LLM integration for error markers. So whenever there's an error marker, I can click here and fix with AI. That's also calling an AI agent in the background, but it's not in a chat way, right? And these are actually the use cases that are super efficient and very, very nice to implement, because those give you very good context. And all of that is built really to be flexibly combined. I will skip over this slide to save a little bit of time to have 1 more minute for the recommendation and the conclusion. So my recommendation is really use Theia AI and start with your tool integration from the start, because actually it is a process that takes a lot of time and experience and learning for your particular use case to get AI integration right. You need to identify the required tool API, the required knowledge, the use cases where it works well, where it doesn't work well, and so on, and really start early with that to gain that experience, and then incrementally broaden and enhance your integration by adding an evaluation pipeline and increase and improve your prompt flows. Better do this sooner than later, because otherwise you would miss the data and the experience to get this right, because this doesn't happen over time. And it's really easy to do, as you've seen. So it's really, with Theia AI, you can really focus on your domain-specific functionality and benefit and reuse from the capabilities and innovation that is provided by you by Theia. So with that, I would like to invite you to start adding AI into your Theia-based tool. Of course, if you're interested, visit us and let's talk. We are thrilled to support also your AI integration project by providing technical consultant, custom development, and all of the other services that we provide. And I'm really looking forward to your questions and to your project. Thank you very much.
Thank you so much, Philippe, for your excellent presentation. That was great. Lots of great information here. So everyone, you better start adding the AI into your tools. So we do have 2 questions from Eyal, and the first one is, it'll pop up on screen. What parts of the AI are running at the back end and what at the front end? I'm referring to the main diagram that's shown in the lecture. Can you explain why each resides where?
Good question. Yeah. So in this particular example of the diagram, it's actually based on a framework called GLSP, where the rendering and the user interaction direction is actually in the front end, and the diagram logic is in a backend. So that's in this case just a process running in the backend. The LLM that I've been using is ChatGPT 4.0, just for this example. So it's obviously not running locally on my machine, but it's provided by OpenAI. So what basically happens when you ask a question is that you send, and you use tool functions, for instance, is that you send the prompt augmented with your system prompt and all of that stuff to the OpenAI LLM. And whenever there is a tool callback, Theia AI will get a callback and will call your handler to do something. For instance, get the current diagram state. Then you provide, for instance, a JSON back, and Theia AI will send that back to the OpenAI, which will then just add it into the conversation so that OpenAI will continue processing until there is the final result, which is then sent back to the Theia frontend. Hope this answers the question.
Great. And then another question from Ayala again. Can you explain what parts of AI are running at the front end and what at the back end, and why this archery was chosen? Here, I put it up here. Archie Wright was chosen. So can you explain what parts of the AI are running at the front end and what back end, and why this Archie Wright was chosen?
Okay, I think it's related to the last question, but now more from a broader context. So Theia AI actually supports, maybe I can bring up this architecture here real quick. So it is super important to Theia AI that it supports all flexible use cases in an arbitrary way. So Theia AI has a language model registry, and you can register language model providers that are running either on the node backend and communicate with an LLM service, for instance, an Ollama Docker container, a Llama file locally, or a remote service like OpenAI. Or you can also implement a language model provider on the front end so that directly your browser communicates with whatever service in the web is available. Of course, it can't communicate with your local processes then, but it can still communicate with your with OpenAI, for instance. And the third option is it can an agent can also do arbitrary stuff directly to, for instance, communicate with an external agent or an external LLM directly. So you have with Theia AI all options, and that's very important also for our use cases and customers, because they very often have their own custom LLMs that they self-host in some way, and then of course they need to have the flexibility where and how to deploy them and how to integrate them.
Great. And then we have time, I believe, for one more question from Rim Bertels. So typically the code is inside a Git repository. Suppose the documentation you want to add, reg or context or to your LLM is another Git repository. How would you set this up practically?
Good question. So I think it depends a lot on the type of artifacts that are in the Git repository, not the fact that it's itself a Git repository, because I think the more challenging part or more interesting aspect is not accessing this information, but making it available for efficient lookup. So if it's documents, then typical similarity search based on embeddings, the typical RAG approach, I would say, is very useful. Then you would worry about chunk sizing and all of that. But if it's a Git repository that contains code, then maybe more relevant would be something like using TreeSitter that allows you to create a condensed map of the entire repository so that it fits really into the context window, and then have, for instance, a step before by the LLM to choose which of the functions it would maybe require more information about, and then have it call you back and ask for more information about this function. So that's another approach to do it. But for code repositories, I would really probably look into either language services to use basically language servers to analyze your code base, or to use something like TreeSitter as a code map to get a good overview of the code and let the LLM find relevant parts of it. But it depends on the use case. Yeah.
Thank you so much, Philip. We are out of time, everyone.